Chloe, do you want to kick us off? You ready to roll?
Perfect. Thank you so much,
Great.
Tanya. That was absolutely fascinating. I really enjoyed that talk. So I'd be more than delighted to have those book recommendations sent to me. So thank you so much for the fabulous introduction. My name is Chloe Thompson. I'm, of course, up there. I'm a cognitive science engineer at AFLAC, Northern Ireland. And of course, my brilliant colleague Amy was up here today giving a talk on DevOps. So in case you missed a little bit about AFLAC Northern Ireland, we are a digital and cybersecurity innovation centre. Sounds absolutely fabulous, doesn't it? And we are the technology centre for our Fortune 500 company AFLAC in the United States. And AFLAC in the United States sells health insurance. We have about 50 million customers worldwide, so you can imagine the amount of data going on there in the background. And we are in 1 in every 4 households in Japan. So we're pretty big players. And of course, myself, I am obviously a cognitive science engineer. That is nothing to do with brains, just to get that out there. I don't know anything about psychology or anything about thinking patterns. My focus is primarily data, artificial intelligence and machine learning. I graduated last summer from Queen's here. I did software and electronic systems engineering. It's a mouthful, I know. You're not expected to remember that. And I have been working at AFLAC ever since, and I'm absolutely loving it. Of course, co-director of Women Who Code, so anything you want to talk about with that, please feel free to come and chat to me. But of course today we're here to talk about graphs and traversing graph technology. You'll get the joke about this later, I hope. But I want to start with some audience participation. This is not rhetorical. Please join in. So my question to you is, how long would you wait? So you're sitting at home, you're scrolling on your social media. How long will you wait for Facebook, which we don't like apparently, Twitter, Instagram, Pinterest, whatever it is, to load? Any takers? Come on. Be confident. 3 seconds. Oh, wow. No patience. Anybody else a little more patient? No? No? Less than half. Oh, you're an app closer, aren't you? Yeah, okay. So let's imagine that you work for AFLAC in the States. And your job, you're an agent. You go out, you sell policies, and that is your bread and butter. You love doing it. You love connecting with people. And you have our application. And that lets you see all your products, all your customers. And that's what drives your business. So it's on tablet, it's on your computer. Whatever it is, it doesn't matter. So you walk up and you're thinking, oh, well, what are my customers like today? And you are really good at your job. You have 14,000 customers. So you're a really good agent, you're making great money. And you are our largest account at AFLAC. So how this currently works at the minute is you want to go see what your customers have, what they've claimed for, what they haven't, and you try to load that feature. So funny story, that feature actually takes over 15 minutes to return. Oh, that was a great reaction. I wasn't expecting that. And it's not because that well, first of all, 2 reasons. The data is unbelievably large. You've got 14,000 customers. But secondly, the retrieval architecture in the background just times out. The data is so large, we can't do anything about it. So you're probably thinking, Chloe, okay, great story. Really want to sell insurance. Why does this matter? So graph technology is what allowed us to take those 15 minutes down to under 60 seconds. So that's a significant saving. And that was all just by migrating traditional tables, relational database, into a graph. So what are we going to cover with graph technology? Because you've heard that it's absolutely amazing and you should be buying into it. So I'm going to walk you through what a graph is, what it looks like compared to a relational database, and also we're going to cover some fundamentals. I'm not going to bore you with theory because who would want that on a Saturday afternoon? And I'm also going to use a use case as well. So we saw Pinterest on the slide before. We're going to walk through real life use case that they use it And then at the end, we're going to tie it all together in a nice bow and tell you how it actually relates to insurance. So you're going to have to keep awake here. Before I tell you about graphs, we're going to touch on relational databases because I'm sure we've got some people who love a relational database in the room. I have no formal education in relational databases. It's all on-the-job experience. It's learning as I've gone. So I'm not here to bash your technology. I'm just here to share something new. But what I do know is that you've got a bunch of tables, you've got your data in your columns, and your columns relate to each other across these tables. And that's what makes your database. And you join these columns together with keys. So for me, being a graph enthusiast, what that means for me is your data are a bunch of nodes. That's these beautiful blue dots up on the screen on the left-hand side. And you have these connected by edges, which are the lovely grey lines. And what they do is they allow us to join these data points together. So we have a node of a data point, and the edge tells us the relationship. What do these two data points mean to each other? So not only can we put data in the nodes in the graph, we can also put data on the edges, and that's what we call properties. This is as much theory as you're going to get. Everybody, don't panic. And what we do is we travel through the graph. Same way you would join columns together in a relational table, but we just walk through from one node to the next using those edges. And that's how we traverse the graph. Yeah, see where the title comes from? Thank you. So for me, this is the concept that clicked a lot more. I'm a really visual thinker and I love diagrams. So when I look at a table, it really just doesn't float my boat. Whereas when I can see my data from point A and I can go to point B, that just clicks a lot more. So in our case, if we think about the 14,000 customers that you are really, really good at serving, in a relational sense, that's around 9 relational tables. And when we do the joins together for those 14,000 customers, we're looking at about 500,000, roughly, rows of data. So you can see how that retrieval very quickly became impossible. And indeed, there are cases where relational is fabulous and it's the way forward, but in our case, to solve this problem, graph was the only way. So now that we've gone through the fundamentals, you've got a bit of theory, you're walking on this graph journey with me, I would like to back it all up with a lovely use case of Pinterest. So please, show of hands that you know what I'm talking about with Pinterest. Okay, we've got some users. This is great. I'm going to cover some fundamentals too. So we're going to give a bit of context with their Pinterest taste graph. And they've been using this since 2014, and it's what's behind their platform today. So they're pretty well established. For the Pinterest newbies in the room, there's essentially 2 concepts to the entire platform. And at the end of this, you're going to be wanting to plan your holiday on Pinterest because it's just so aesthetic. But you've got a pin that's above me on the right, and a pin is an image or a video. It can be any type of content that you want. And you've got some information associated with that pin. So you've got a title, you've got who added it, you've got a bit of a description that tells you what the image or video is about. And then you've got a board. And a board's a collection of pins. So you'll see here, I did a beautiful search for holiday and travel inspiration. Got a few ads in there too, so we can just ignore the candle in the center. So let's talk about Helen. And she's sitting at home. It's a Saturday night, middle of winter. She's watching Strictly Come Dancing. She's getting really bored with Anton Dubek. And she's got her cup of tea, and she lifts out her phone, and she starts scrolling through Pinterest. Just planning that summer holiday, and she's wondering where she's going to go, and looking at all these beautiful European holiday destinations. And she sees this pin for Malta. Now, I've never been to Malta, but it was the first pin I got recommended, so maybe I'm Helen. And you can see here, it's a beautiful cityscape architecture, cobbled streets, sunny sky. So Helen, unoblivious, likes the pin and continues on her scrolling journey. But what she doesn't realise is in the background, as soon as she liked that pin, she triggered an action. And it was everything to do with behind that pin, there's a bunch of underlying data. It's what we talked about, the description, the tagline, and the person who added it. It's all associated to that pin. And that pin's also categorised. That's the beautiful blue circles. So it's a travel pin. It's specifically to do with Europe. Maybe there's another thing in there about the fact that it's a summer holiday destination. So you've got something called an interest there in the background. And when Helen clicked that pin, she triggered a process. And we're going to get into that in a second. But let's talk about Helen's action. So if we bring back the relational versus graph concept, I've made the tables up, but that's completely fine. The relational tables here on the right-hand side is what I imagine the tabular format to be. So we have Helen as a user. She likes the pin. So we have a table that says user 02 liked pin 123. What that also connects to is another table, which is our user table. That's all our information about Helen. Her user ID, her name, her email, maybe what country she's from, what language she's using in the app. And then we have the pin table, and that's all the information about the pin. Where have we stored the image? What's the description? What's the headline? And what's the pin ID? So you can see how that, as it builds up, those tables could get quite complex. If you look on the left-hand side, you've got it as a graph concept. So we have Helen herself, a user, as a node in this graph, and you have the pin as a node in the graph. And the nodes contain the same information that is in that row in the table. So Helen's user node has that it's Helen, we have her user ID, we have her email, all the same information. And then on the other side, we have the pin, same thing. Where is the image stored? What does it say in the description? And we link those two together with an edge. And that is the edge that Helen liked the pin. And that's as simple as it can be. So this format, we call this a triple because it's made up of 3 elements. We've got a node, an edge, and another node. Or if you want to really get into semantics, it's subject, predicate, object. But of course, Helen wouldn't like just one pin. She's there for the entire duration of Strictly Come Dancing. She's going to be scrolling for quite some time. So she goes through the app, she starts liking more and more pins. And we start expanding out that triples concept, and we get this larger graph that's on the left there. And you can see here that Helen has the initial pin that she liked, but she's also liked a second pin. And we link those together with the same liked by edge. And of course, pulling back that pins and boards concept, it's very rare that a pin exists outside of someone's board. So we can link the pin to the board that it sits on with another edge. So we have a node for a board, and it maybe says what the board name is, what the ID of the board is. And when we link those together, we say that the pin is in the board. And slowly but surely, we start to build up this graph of Helen's interactions with our platform. But this is all great. You know, we can see what Helen's done, but what does it mean for a pin underneath? What does it mean for the data for those? Well, funny enough, Pinterest have over 200 billion pins. So if we had a tabular data format, I don't even want to get into how messy it could be, possibly. I'm not an engineer there. But if we take that initial pin from Helen and we think back to the pin being in a board, it's most likely that I might like the same pin as someone else, and I'm going to put it in my board, but they've maybe put it in their board as well. So we start to build up that a pin is related to multiple boards. So you can see here, Helen's multi-pin goes inside travel goals, travel aesthetic, travel and lifestyle. There's probably about 10 others there. And we start to see that this doesn't look a bit like a graph. Yeah? No? Okay, that's fine. And we can expand this out. So you have that one pin, but Pinterest has 200 billion pins. So you're not just going to look at one. And we can build this out to show that we have multiple pins connected to multiple boards. It's many, many relationship here. And if you think about this concept, all of a sudden you can see how complex the taste graph could be. And it's this graph that underpins, the entire recommendation system behind Pinterest. So for Helen, as soon as she liked that initial pin, she triggered a process. I said this was going to come back again. So she triggered an algorithm called Pixie, which sounds really cute. But what Pixie does is it starts at that initial node that Helen liked, and it walks the edge to find the board that it's within. So it's in that travel board. And once we hit the travel board, we look for all the pins that are within that board. And once we get all of those pins, we go to the boards that they are in, and we keep going and going and going until we have hit a certain limit of however many pins we want to look at. And as we start to traverse and walk through this pin and board graph, we can see what type of pins there are, and we can rank them based on how relevant we think they are to Helen's initial pin. So as soon as Helen liked that pin, she's automatically going to start seeing more travel content. And this is how Pinterest and other social media platforms get really, really good at recommending you other products. So Helen's finally finished that cup of tea. Strictly Come Dancing's finished. She's on to the 10 o'clock news, and she's planned out her entire holiday. Just from the fact that she was recommended a few pins, she's built out her beautiful holiday board, and her holiday is planned to complete tea. She's completely finished. But this is all well and great. But what does that mean for Aflac, and what does that mean for insurance? Well, if you take Helen and you think about her in an Aflac sense, Helen is a policy holder. Same way any of us go out and we buy car insurance or house insurance, we own a policy with that company. We're a policy holder. And what Helen's policy is a board. It's a Pinterest board. And it's full of pins. And when I say full of pins, I mean it's full of benefits. It's things that she is covered for. It's things that she's claimed for. And it's possibly things that her dependents are also covered for as well. And you can see here that we have built out Helen's Aflac journey with us, and we've mapped it into a graph. So we have Helen, we have her beautiful dependents, we have the relation that they are to her. We know that Helen holds a certain policy with us. That policy covers possibly dental, vision, hospital appointments, doctor's appointments. And under that policy, we also know what Helen has claimed for and what her dependents have claimed for as well. And if we think about this mapping of our customer, we're seeing everything from our customer sense down to the most granular level of what they have benefit-wise. And we can go even further than that as well. And it's this graph and this concept that took those 9 tables and over 500 million rows of data and that intense 15-minute wait, maybe sitting in front of your customer for your data never to return, down to the 60 seconds. And at this point, I'd been working in graph technology for slightly over a year. And it wasn't until this exact use case and this moment that connected all of those dots for me on how powerful this technology could actually be for our customers. And it actually brought a huge amount of value as well. And unfortunately, that is the end, possibly, of my time today. I'm seeing Danielle giving me the eyebrows. But I hope I have piqued your interest in graph technology. And if you are scrolling on Pinterest or any social media platform, that you spare a poor, sad thought for that pixie in the background that's doing all the hard work for you. Thank you very much.
Do you have any questions for Chloe before you wrap, or? Okay. Oh, there is, sorry, the light is really bright up there. Talks amongst yourselves whilst I get up these stairs. It's been a very sedentary 2 years, folks. More than usual.
It's too much to. Thank you for the lovely presentation here. I just have a quick question. Do you have any example of this being the graph technology for the databases? Any example databases?
Do you mind repeating the question? Because I can't hear you from all the way down here.
Sorry. Sorry for that. Am I audible now?
Yeah.
Yeah, okay. So I just want to ask any example databases used for graph technology and the latency improvement you mentioned. So is what exactly used in the technology? Is it something like in-store kind of, in-memory databases sometimes used for improving the latencies? So is it something similar to that?
Yeah, so there's actually there's two parts to the question. So the first is, if you want to give this a go, there are definitely a lot of open source data sets, especially on Kaggle that you've heard mentioned today. One of the most popular challenges is movie recommendations, so you can maybe give that a go. In terms of technology, there are an abundance of ways to implement a graph. So there are actually two different types of graph databases. I have technical slides on them later, but I will not bore you. And you can also use different technologies on AWS compared to Azure and Google. So what we primarily use is Amazon Neptune. It's their graph storage system. And you can also, there's a few different languages too. There's Sparkle, there's Gremlin. It really just depends on your particular use case and which graph you go for in terms of what you use.
Any others? Okay, good. That's a lot there. We do encourage questions, but it's really busy. Thank you again, Chloe. Yeah, thank you, Chloe. And as Chloe mentioned, she is one of the directors of Women Who Code, who, I mentioned earlier, I thank Jill for coming along today to be part of this community. And I really did mean that. It is a community, and Women Who Code are kind of at the forefront of that. They organise a lot of meetups. Throughout the pandemic, they've kept, coffee calls going like every other Thursday. So if that's something you're interested in, please stay in touch, look them up. We also have the Women in Tech Belfast group who organise a lot of meetups. I think the next one they're doing is on networking, which, if you're not as comfortable with this today, you want to get some advice, get the opportunity to meet more folk, look them up.